Autopilot Methodic Configurator. Why it exists, why use it, what it does, and how to use it.
Autopilot is a firmware to automate the operation of autonomous vehicles. It supports many different flight controller boards, supports hundreds of different additional sensors, has many propulsion systems that it can use, different vehicles. It's a very, very flexible system. That flexibility comes with a price. It must be configured and tuned to operate correctly. Only then can it unfold its potential. Configuration is a bit complex. It requires many steps. The interdependency between these steps is sometimes not very clear. Extensive documentation exists and it is spread over 1,600 unique web pages. Many users end up incorrectly configuring their vehicles. For that reason, the team decided to create ArduPilot Methodic Configurator, a software dedicated just for the purpose of configuring ArduPilot and nothing else. Common ArduPilot configuration pitfalls addressed by the ArduPilot Methodic Configuration. Missed mandatory configuration steps, wrong sequence of steps, a lot of trial and error that could be avoided. The parameters are spread over different prefixes and are sometimes hard to find. When doing a configuration step, where is the relevant documentation for that particular step? Where is the relevant documentation for the flight control that you're actually using? And is there a way to know why you did such a parameter change? Why the parameter that you have right now has that value and not some other value? What does ArduPilot Methodic Configurator do? First of all, it's not a full automatic configuration system. It's not capable of fully automatically configure your vehicle. You're still going to have to do something. When you're using something like Mission Planner, Q-Ground Control, or any other ground control station software, the configuration type that you're doing is manual. You can do every single step by any order that you choose. So you have a very high degree of flexibility, but it means that you need to take all the decisions. Here, it's semi-automated. So you're kind of guided on which step you need to do and which step you need to do after that one. These other ground control stations do not explain you what you need to do. Methodic Configurator explains you what you need to do, explains you also when you need to do something, and explains you also why you're doing that thing at that moment and not before the other step or after any other step. So the configuration method is different. When you're using a ground control station, you usually have a different menu for each task. So the menus are adapted to that particular task. But many tasks have no menu whatsoever. So you end up having to dig into the over 1,200 parameters that are present in the ArduPilot. Using the methodic configurator, each task only presents you a relevant subset of the parameters. So you'll never see the 1,200 parameters in one screen. You only see parameters that are relevant for the task that you have to do. So all you need to do is to concentrate on those parameters and no other parameters. Parameter documentation is usually only presented in the full parameter tree view. There is no documentation if you are using any of the other menus. On ArduPilot Methodic Configurator, you always have the parameter documentation for every single parameter. Just hover with a mouse over the parameter name and you'll see the documentation. It does not display the relevant documentation for the task that you're doing. You have to go and find that documentation somewhere in some website. On the ArduPilot Methodic Configurator, the information opens automatically in the background for you. They do not make sure that you do not forget a step because they don't impose you any sequence of steps. We do impose you a sequence of steps, so you end up not forgetting anything because it works like a checklist. The other tools, most of them do not check that the parameter gets correctly written to the flight controller. We always perform a write to the flight controller and then a verify to make sure that that parameter value has been modified on the flight controller. When you're trying to reuse the parameters in other vehicles, you cannot really reuse them. You have to hand edit them, or you need to reconfigure the vehicles. You need to do some stuff to reuse the parameter from vehicle A in vehicle B. With ArduPilot Methodic Configurator, you can do that. It will not give you all the parameters from vehicle A to vehicle B, so it uses a trick. It only uses a subset of the parameters that you can export between two vehicles, but it does that out of the box. You are not able to document why you changed the parameter. So once you configured your vehicle and you want to go back to it 5 months later, you have no idea why the parameters have the value that they right now have. With a methodic configurator, you can add that information. Regarding tutorial and learning resources, there are many tutorials and many videos that use any number of ground control stations to set some parameters, but those are not integrated in a single place. Here we have in a single place, it's content aware, help integrated in the software itself. When using any other ground station, you do not get automatically installation of Lua scripts. With the configurator you do get, we automatically create a backup of your entire parameters when you connect to the configurator. So before doing any parameter change, you always have a backup. If you connect 10 times to the methodic configurator, you'll end up having 10 different backup files. This is the ArduPilot methodic configurator website. You can access all the required information to use the software. Start by seeing a presentation, then the table that we already seen, and then there's a quick overview of the entire process. We start by selecting the vehicle components, then install the software, the ArduPilot methodic configurator. You need to also install Mission Planner, and you need to use the latest ArduPilot firmware version for your flight controller. Then using the software, we'll input the vehicle components and the component connections to the flight controller. The first step is to perform IMU temperature calibration. This step is optional. Every step that's optional is clearly marked as optional. Then you assemble all components. You do that after you perform the temperature calibration, because the temperature calibration requires you to put your flight controller in a refrigerator, and it's a lot easier to put the flight controller in the refrigerator if it's not connected to your entire vehicle. After that, we do the basic mandatory configuration that consists of a couple of steps, configuring every single device driver for every single sensor and actuator that you have. Then you calibrate all the sensors in Mission Planner. And after that, you start doing the configuration and calibration that's required for the first flight. Once all that is done, you assemble the propellers and you perform the first flight. After that, there is some steps for the minimalistic mandatory tuning that use the data from that first flight to set some parameters. Then there's standard tuning. This step is optional, but it does improve the characteristics of your entire vehicle. There's improved altitude under windy conditions. Again, this step is optional. System identification, this step is also optional. Position controller tuning, this is optional. And the very end, the everyday use. So this changes your flight controller from a configuration that is meant to do flight tests to a condition where the flight controller is configured for production use. So let's start with the first step. You need to install the methodic configurator on Windows. So you just click here and you follow the steps here for the Windows installation. The Linux installation and Mac OS installation is a little bit different. On older distributions, you just execute these two commands here and that's it. On newer Linux distributions with virtualenv, create a virtual environment for the methodic configurator and then you execute it. Then you should download and install Mission Planner, and after that use Mission Planner to install the ArduPilot firmware on your flight controller. There are multiple use cases for this software. First use case is using the methodic configurator software for the first time, so you need to create a project. The second time that you use the software, you can open that project. There are other use cases, like creating a vehicle configuration based on a correctly configured vehicle, review or edit configuration files without requiring you to have a flight controller connected, and how to rerun the procedure after changing a vehicle component. As an example, if you change the propellers, what steps do you need to repeat in order to configure your vehicle, and what steps can you skip?
This video presented why ArduPilot Methodic Configurator is built the way it is, what it does and how it does it, and the next video will present a more hands-on approach on how to install, start, and use the software. Thank you.